This is section 3, continuity, example 4. So for example 4, we're trying to figure out what values of k would make the following functions continuous. These are piecewise functions. So first, we need to make sure that each piece is continuous, and then we'll worry about what k is. Well, if you look at each piece, they're all polynomials. Polynomials are continuous everywhere. That's what that chart said. So we don't have to worry about that. Now we just have to worry about making sure that the overall thing is continuous. And the only place we would worry about it being continuous, since each piece is already continuous, is where it switches from one piece to the other. So for part A, it would be at 1. Well, in order for that to be continuous, first it would have to exist there, and it does, and it will because for each piecewise function that we're looking at, it's defined on one side or the other. So that's not going to be an issue. But the limit also has to exist. And when you're talking about piecewise functions, the limit existing is going to be the issue. So in order for the limit to exist, we need the left-hand limit to equal the right-hand limit at the place we're worried about. Well, for A, we're worried about 1. So we need to make sure that the limit as x approaches 1 from the left is equal to the limit as x approaches 1 from the right. And to make sure that's the case it's actually very simple. All you're going to do is take 1 and plug it into each side and set them equal to each other. So we'll have 3 times 1 minus k equal to 5 times 1. Okay, well, that's just 3 minus k equals 5. Negative k equals 2. So k equals negative 2. And it's really that simple. All right, try not to overthink these. Now for part B, it looks more complicated, but it's really not. All right, there's actually very little wrong with it. So first, hang on, there's a typo here. That's supposed to be 30. That's supposed to be a positive 30. Okay, now it's fixed. So we're here worried about negative 1. So we need to make sure that the limit as x approaches negative 1 from the left is equal to the limit as x approaches negative 1 from the right. Okay, so we're going to plug negative 1 into the top equation, so we get 2k squared times negative 1 plus 4. And then we plug it into the bottom equation, so we get 30 times negative 1 plus 2. All right, so let's see what happens. We're trying to solve for k. So we get negative 2k squared plus 4 equal to negative 30 plus 2. Well, we do know what negative 30 plus 2 is, so that's no change. So it's negative 28. All right, so then we subtract 4 from both sides, so negative 2k squared is going to be equal to negative 32. K squared is going to equal, divided by negative 2, we get 16, which means k equals plus or minus 4. And that's the answer.